In the late 19th century, the world was transformed by a quiet but profound force, electricity. It rewired industries, enabled entirely new forms of progress, and reshaped the fabric of daily life. Now we stand at the threshold of a similarly far-reaching shift, this time driven by artificial intelligence. Like electricity, AI is a general-purpose technology. It doesn't belong to just one sector, it touches all of them. From healthcare and finance to public services and education, the arts and even professional sport, its influence is already being felt everywhere. So the real question is no longer if AI will change your world, it is how you will choose to engage with it and whether you'll shape that change or simply respond to it. But before we dive into the complexities of the technology, let's pause for a second to think about what AI really is all about. AI at its heart is about advanced statistical techniques, learning from data, making predictions, and helping us solve problems that were once too large or too complex. And with that power, well, as with all things, with great power comes promise, but also risk. It's clear that AI holds the potential to change the world. And with that power, well, as with all things, with great power comes promise, but also risk. AI holds immense potential. It's already helping doctors detect diseases earlier, supporting communities through better forecasting, and even tackling global challenges like the UN Social Development Goals. So it's easy to frame AI as a great tool for adding value, for improving consistency, efficiency, and access to services. But here's the key. To use AI well, we must understand its limitations. AI can make decisions, automate tasks, and even learn on its own. But it doesn't understand context like we do. And that's where the risks come in. You see, AI systems can introduce bias into decision-making, perpetuating or even amplifying existing inequalities. They can also lead to a loss of privacy, as sensitive data is collected, processed, and sometimes shared without sufficient protective measures. They can suffer from a lack of transparency, leaving us uncertain about how or why a particular decision was made, especially in high-stakes contexts. AI systems don't exist in a vacuum. They interact with people, policies, and societal values. The decisions affect lives. At Oxford, we embrace the idea of dialectic discourse, an approach where there's no simple answer to a complex question. Take fairness, for example. Should we aim for equality of opportunity or equality of outcome? These aren't just technical decisions, they're ethical dilemmas. That's why safe innovation is our guiding concept. We believe AI must be governed in a way that both encourages creativity and protects people. And we're not alone. Around the world, policymakers, companies, and civil society have come together to set ethical principles for AI, from the EU's ethics guidelines for trustworthy AI to the OECD's recommendations. The common ground includes principles like, firstly, benefiting society, meaning that AI systems should be designed to actively promote well-being and contribute positively to individuals and society as a whole. Secondly, non-malfeasance, requiring these systems do not cause harm and avoid outcomes that could negatively impact people or communities. Thirdly, autonomy. This emphasizes the importance of preserving human agency, ensuring that individuals remain in control of decisions that affect their lives. Fourthly, justice, which calls for fairness in both process and outcome, guarding against discrimination and promoting equal treatment across groups. And finally, explainability, which ensures that AI systems can be understood, not just by experts, but also by those affected by the decisions. These principles are essential, but they're not always easy to apply. Here at Oxford, we work to bridge the gap between high-level ethics and practical action. Our approach, helping organizations translate ethics into verifiable criteria, so you can design, develop, and deploy AI systems that are not only innovative, but also trustworthy. So as you explore AI in your own organization, remember this balance: innovation paired with responsibility. Stay curious, stay engaged, and recognize that safe AI isn't just about what the technology can do. It's about what it should do. Before you've even started your working day, AI has already been hard at work. Your spam filters have organized your inbox during the night. Your phone unlocked, recognizing your face. The music playing in the background, chosen by an algorithm that's learned to predict your tastes. The reality is that AI is already woven into the fabric of everyday life, quietly, efficiently, and often without us realizing. But the real question isn't whether AI is here, it's how we harness its capabilities to create meaningful value. Let's start with the essence of AI's value: prediction. AI excels at making accurate predictions from large and complex data sets. Predictions, in turn, reduce uncertainty and enhance decision-making. That's where the true power lies, not just in automating tasks, but in enabling better decisions. Consider a familiar example: traveling to the airport. An AI system using real-time data on traffic and weather can predict the best departure time, helping you avoid delays or long waits. Simple, yes, but powerful. Better predictions lead to better outcomes. Across contexts, AI is adding value in two key ways. Firstly, making existing processes better. Think about optimizing supply chains, enhancing customer recommendations, or detecting fraud more accurately and efficiently. In each case, AI supports human decision makers with actionable insights. The second way in which AI is adding value is creating new products and services. AI doesn't just improve what we already can do, it can create entirely new offerings. From personalized healthcare diagnostics to smart assistants that tailor services to individual needs, AI opens doors to innovation. But here's something important to remember: AI doesn't operate alone. Yes, data is the fuel that powers AI, but there are two other crucial complements: human judgment and action. Let's think about those for a second. When thinking about human judgment, it really boils down to AI providing predictions, while it's still up to us to interpret those predictions, to apply context, ethics, and experience. That's something AI cannot replace. And secondly, a prediction is only valuable if it leads to action. AI gives us insights, but it's the decisions we make that drive results. Together, data, human judgment, and action form the triangle of value that AI enables. There's also a practical limit to what AI can offer. Yes, more data can improve predictions, but only up to a point. After a while, each additional data point adds less and less value. So organizations need to think strategically about what data they collect and how they use it. More isn't always better. Ultimately, AI is a tool, albeit a powerful one. It can enhance human productivity, support better decisions, and unlock innovation. But like any tool, its value depends on how well we use it, understanding its capabilities, its limits, and the need for human oversight. So as you look at AI in your own organization, ask yourself, where can AI enhance what we already do? Where might it help us create something entirely new? And always remember, the greatest value comes from when AI and humans work together. Most of us are familiar with images of AI from the movies: disobedient robots, self-assembled armies, sabotaged infrastructures. And in the real-world conversations about AI, certain terms can often carry that same cinematic weight: sentience, consciousness, artificial general intelligence, or AGI. If they sound more like science fiction than business strategy, it's often because they are. But these ideas still matter. So let's take a moment to clarify what they mean and why they remain important, even if they haven't yet arrived. In discussions about AI, terms like sentience and consciousness often surface, so it's worth being clear about what they actually mean. Sentience is the capacity to feel pain, pleasure, and emotion. Consciousness goes further. It implies self-awareness, the ability to reflect on one's own thoughts and experiences. Understanding these distinctions matters, especially as we evaluate the real risks and limitations of today's AI systems. Despite the growing capabilities of today's AI, language models, image generators, autonomous agents, none of them feel, understand, or introspect. They process data, but they have no awareness like we do. To be clear though, there's no engineering path today to building conscious machines. But here's the catch: AI doesn't need to be sentient to be risky. The real risk lies in capable systems acting without understanding. AI is already making decisions, approving loans, detecting fraud, managing supply chains. But when these systems pursue poorly defined goals, they can scale the wrong decisions across millions. Not out of malice, but out of misalignment. These failures are already happening, and as AI gains more autonomy, oversight becomes harder, not easier. What about artificial general intelligence, or AGI? AGI is the idea of an AI that can perform any task a human can, and improve itself over time. This leads to the concept of the singularity, a rapid, recursive explosion of intelligence, potentially beyond human control. It's a powerful idea traced back to John von Neumann and expanded by futurists like Ray Kurzweil. But let's be clear, AGI doesn't exist yet. But if it does arrive, it will bring about transformational challenges. However, that should not distract from the fact that we already face serious ones now. AI is already raising profound societal challenges. It is reshaping the future of work, displacing certain roles while creating others. It is contributing to economic disparity as access to advanced technologies becomes uneven. It is being used to enable manipulation through misinformation, undermining trust in democratic institutions. And increasingly, AI systems are operating beyond the reach of existing regulatory frameworks. These challenges do not require machines to be sentient. They arise from capability without accountability, and that is where the real risk lies. So let's not get distracted by the science fiction. The real question isn't when AI will become conscious. It's how we govern systems that are already powerful, autonomous, and deeply embedded in our society. Sentience isn't a threat, misalignment is. And ensuring that AI acts in line with human values, that's our responsibility now. When we talk about how machines learn, we're really talking about how algorithms extract patterns from data to make decisions, predictions, or actions. This diagram helps us map the territory, starting from the broadest idea, artificial intelligence, and working inward to the core learning techniques. Let's walk through it. At the broadest level, we have artificial intelligence, the umbrella term for systems that mimic human-like intelligence. Under that umbrella sits machine learning, AI that learns from data rather than being explicitly programmed. Machine learning is the engine of modern AI, and it's made up of three main types: supervised learning, unsupervised learning, and reinforcement learning. Let's break each of them down. In supervised learning, we train the machine using labeled data, pairs of inputs and known outputs. Think of it like flashcards. We show the system examples, say images of cats and dogs with labels attached. The algorithm learns to map inputs like pixels to outputs like cat or dog. There are two main tasks here: classification, that's predicting categories like spam versus not spam, and regression, predicting continuous values like house prices. Once trained, the model is tested on new data to see how well it generalizes. Unsupervised learning works without labeled data. Here, the algorithm is left to find patterns on its own, to group, segment, or detect anomalies. A common application is clustering, say grouping customers by buying behavior. No one tells the model what to look for. It explores the data and surfaces structure. Another example is anomaly detection in network traffic or financial fraud. Finally, we have reinforcement learning. This is the most adaptive and interactive form of learning. Here, the agent learns by doing, interacting with an environment, receiving feedback in the form of rewards or penalties, and gradually improving its strategy. Think of a chess-playing AI. It starts off making random moves, but learns over time which actions lead to winning and adjusts accordingly. Some of the key features of reinforcement learning is that it learns through trial and error, balancing exploration and exploitation, and generates its own training data through experience. Across all three types of learning, a technique called deep learning has become especially prominent. Deep learning uses neural networks, layered systems inspired by the human brain, to process massive amounts of data and make complex predictions. Whether classifying images or translating text, deep learning is the foundation of many recent breakthroughs. So, to summarize, supervised learning learns from examples. Unsupervised learning finds patterns in the unknown. Reinforcement learning learns from the actions and consequences. Each approach has its place, and together they form the backbone of how modern machines learn. Neural networks are one of the most powerful tools in modern AI. Inspired by the human brain, these systems learn to recognize complex patterns through layers of artificial neurons. Let's take a look at how they learn. Deep learning is a technique that uses neural networks with many layers, also called deep neural networks. These networks can be used across supervised, unsupervised, and reinforcement learning setups. Architectures like convolutional neural networks, or CNNs, help with image recognition. Recurrent neural networks, or RNNs, work well for time sequences. And transformers have revolutionized natural language processing. Now, let's walk through how a neural network learns, using a simple example. In step 1, the model is shown an image of a dog, but it predicts cat. Then a human or a training label corrects that answer. The model then updates its internal parameters, tiny weight changes across thousands of neurons. This process repeats hundreds of times and thousands of times on new images. Over time, the network learns to detect key features like fur texture, ear shape, nose and tail differences. Eventually, the model can distinguish between similar animals, like a husky and a wolf. But here's the challenge. Neural networks don't explain themselves. Sometimes they learn the wrong pattern. For instance, if all the wolf images happen to show snow, the model might start to use snow as the signal for wolf. This is called the black box problem. We see the outputs, but the decision-making process is often hard to interpret. As training progresses, the network keeps adjusting, reducing its error rate with each iteration. To improve further, developers use validation sets to avoid overfitting and more diverse training data, and use techniques like dropout, normalization, and early stopping to stabilize learning. These refinements help the network generalize so it can handle new, unseen data. Neural networks don't just memorize, they build representations. They learn to extract meaning from images, sounds, and words, layer by layer. But their power comes with complexity. And that's why understanding how they learn is essential for building systems that are not just accurate, but also safe, explainable, and trustworthy.